Hello everyone, it's October 1st. Alright, let's get on to it. Water bottle again. Water bottles 2. You're given two integers, num bottles and num exchange. Num bottles represent the number of full water bottles that you initially have. In one operation, it can perform one of the following operations. Drink any number of full water bottles, turning them into empty bottles. Exchange num exchange empty bottles with one full water bottle. Then increase num exchange by 1. Note that you cannot exchange multiple batches of empty bottles for the same value. For example, if num bottle is 3, and then you cannot exchange 3 empty water bottles for 3 full bottles. Wait, what do you mean? You cannot exchange multiple batches for the same value. Oh, you can only do it once. They have so each one can only do it once. So the number always increasing. So example 13 and 6. So we have 13 empty bottles, num exchange, bottles drunk. So I say 13 full bottles. I drink all 13. Num exchange can do 1 exchange. Will give us 1 full bottle with 7 empty bottles and with a 7, so I can drink. Oh, then I can exchange again. Wait, hold a second. Oh, you can only exchange it once. You cannot exchange this twice. You cannot get 2 water bottles out of it. You can only do once, and then this can another one, and you will drink it, so it'll be 15. So we want to know, I think it's just simulation, because if you don't drink all of them, so you have the starting water bottles, right? So you can drink, and then you can try to exchange it once. Yeah, you can drink that much, exchange it once, and then drink that much. Because each time you exchange, you can only exchange that amount. So like if you have 10, right, and then exchange is 3. Right, so I can just, because it's 3, so I can drink 3. Right, I can drink 3. So this is full. This is num exchange. And this is drunk. Right, so we do that. And then, actually this is where we start. Okay, in one shot, I'll drink 3. And I have 1 water bottle, and I'll give it back, so that becomes 4. Then I'll drink 4. Right, I'll drink 4, and then I'll plus 1, so it'll be 5, and then it'll be 5. Then I'll drink 5. Then it will be 12. And then this will be 1. Because I drink 5, I give 1, and so it'll be 6. And at the end, I will drink 1, so it'll be 13. Yeah, I think we can just simulate this whole thing. I think a simple simulation would do. So int result, right? And its number of bottles, while num bottles is larger equal to num exchange. What's going to happen is res or plus equal to num exchange, and num bottles or minus equal to num exchange. Actually, we're going to say plus equal to 1 minus this, and num exchange plus plus. And when we do this, when we get out, we'll return res plus num bottles. Okay, so at each round, we can only exchange at most num exchange number of bottles. Only drink and then exchange. Yeah, I feel that is the key to make the whole thing much easier to handle. Yeah, let's say 100 and 5. 100 and 100. 1 and 1. Right, there's a couple of different scenarios. Alright, that looks to be solid. Now we can try it. Simulation is the way. Simulation is the way. 2 milliseconds. Is there a better way? I don't know. Maybe there is a mathematical way, because I saw there's a... Maybe there is a math way. So basically what we do is adding these together, right? Adding these together and see. So let's say we can drink like X times. So basically we can do, yeah, because we just like say how many times do we have to, like 3, in this case 3 plus 4 plus plus something, right? We can say plus 3 plus X, right? 3 plus X, that's the number of times. So this is the exchange, and it will stop once the exchange becomes bigger than the full, right? Because the full will start with 10, and each exchange will just add 1. Each exchange will just add 1. So eventually this is gonna be, at the end, it will be plus X. There's the first exchange, second exchange, third exchange, right? So basically this will plus X. So we want to know at which point this is smaller than 3 plus 4 plus all the way to 3 plus X, because that X value is the maximum you can get, because you cannot keep exchange. So in this case, it's going to be 3 plus X times X divided by 2. Right? And we can, this is actually 6 plus X. So 6X plus x squared is 20 plus 2x is smaller than this. Oh, so it's x plus 4x, right? It needs to be larger than 20. So what is, and x has to be positive, right? So we'll pick some x. The first x, so the first x is equal to 3, which means it's only this, which means we can simplify this because the total number exchange, this is the number that we actually drink, right? And each time we drink, we add 1. So it's just num exchange. We can say num bottles, okay, equal to B. And num exchange equal to E. What you want is to find the smallest x such that this is smaller than e plus x multiplied by x divided by 2. All right, so it's 2b plus 2x is smaller than x squared plus 2ex. So it's x plus 2e minus 2b. Nope, my bad. Minus 2. 2e minus 2. X is larger than 2b. So it's 20, it's 4. So we put a number in and then we just find the first one and then we do it. So we can try. A bit more math. So let num bottles equal to B, num exchange come in equal to E. I saw that you left me a gift. All right, so suppose we can exchange. So at the end of the day, right? At the end of the day, we will have drunk B number of bottles plus all the exchanged bottles. Suppose, and since, suppose there are, suppose we can have X exchanged bottles. All right. Then to fulfill these X exchanges, we need to accumulate empty bottles as such. E plus 1 plus plus E plus X, which is equal to E plus X times X divided by 2. Right. On the other hand, the available full bottles to drink is B plus X. So this exchange scheme will end if B plus X is smaller than 2E plus X times X divided by 2. So all we need I can just keep one more step, which expands to X squared plus 2E minus 2 times X is larger than 2B. We need to find the first X, right, that makes this possible. And the answer would be B plus X. Okay, so in this case, for int X equal to 1, let me just go X equal to 1. While X times X plus 2 times num exchange minus 2 times X is smaller or equal to, what about equal? So maybe I think equal should be here. Which means here should be smaller than 2 times num bottles. Alright, I think it makes sense. X plus plus, because by the time it come out and I will return num bottles plus X. Okay, let's give this a shot. That ain't right. The first one's not right. Output 16, expected 15. So the first one, num exchange is 6. Isn't that the one that we tested? Actually, no. So x squared plus 10x larger or equal to 26. Yeah, x equal to 3. Oh, the answer is 15. Oh, really? Answer is 2. Two rounds. Huh. Yeah, 2 rounds. I have 15. Right? So this will be 6 plus 6 plus 2. 8. 14. That's 14. This will be 14. This is 15. But we cannot do another exchange because it has raised up to, so like 2 rounds. After 2 rounds we have 1 left, right? After 2 rounds, so like after 3 rounds it's bad. Huh. So after 2 rounds, we can still do 1 more exchange, but on the 3rd round, we cannot. So basically means we cannot do another exchange. There is some off by 1 issue here. Now how about this one? This one did 3 rounds. Right, because 3, 4, 5, no. There's a 2 rounds, which means I do 6 and then 7, right? And I want to do 8, and it's bad. This is 3 rounds. 3 plus 4 plus 5, that's 12. Right, 3 rounds, it's 12. And then 3 rounds. And here is going to be 13. Right, so one side is 13. The other side is 12. So this is still larger. So we can do 1 more. But we can't. That's why it's 13. Here, 2 rounds, 6, 7. Give you 13. And now on the other side is 15. So 15 is larger than that. So we can do another round. Right, we can do another round. But But you can't. Hold on. Rounds. X should be the rounds. So 2, this should be -1, I feel. Right, so actually, no, I think it's b plus x minus this is the difference. The first time this is smaller, then because it's equal to, we can still do more. But if it's smaller than exchange plus x minus 1. That means it's the end. This is the end. We cannot do more exchange because the leftover is smaller than what we have. Okay, so let's expand this then. So it's 2b 2x minus 2ex. Actually, I think we should just put them. That's 2e minus 1x minus x squared, the smaller e plus x minus 1. Okay. So if I move things around, so I move x to the other side, so it's x squared, right? And then these two can merge together, so plus 2e minus 1 minus 2 and minus 3 x, right? I'll go to the other side, should be larger than 2b minus e plus 1, and then I have a plus 1, so this is actually minus 2. So this is the new thing. So x squared plus 2e, well, it's smaller or equal to, well, this is larger than LVN, so 2 times bottle minus num exchange, right, minus num exchange plus 1. Let's see if this one's right. Oh, it's almost 1-on-1. Good test case, by the way. So 1 doesn't work, so I need to go x equal to 2. 2 failed. Okay, I don't understand. X equal to 1. So this is 2. 1 smaller than. Everybody's 1. One smaller than 1 that fails. Right? Fails. That means we can do one bottle. Oh, I think it's plus, and I think it's plus x. It's not minus 1. This is the next round. It's the next round. Don't have this. Do 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 do. So basically, we don't have this. How about this one? Huh? Still doesn't work. Oh, I think you also miscalculate this. This should be 2e and 2x. Ugh. But this is right. Wait, hold on. Now I'm not sure. So this is saying after I get x number of exchanges, right? On this side, I got this much of bottle. On this side, x number of exchanges. So 1 exchange. We just add this 2 exchange. Okay, we have that many exchange. Once it's done, right? And then if its value is smaller than the next exchange required, this is the next exchange required. So this actually is 2x, and this actually have to be 2. Alright, so the 2 actually get cancelled. Hold on. So 2b plus 2x minus 2e x minus 2 minus x squared. Right, x squared plus x smaller than 2e plus 2x. So we have 2x and 2x cancelled. So we have 2b minus 2e should be smaller than x squared plus 2e minus 1x. So x squared 2e minus 1 x minus 1x is larger than 2b minus 2e. 2 times e. How about this one? This one's right. Oh, took a few tries. Jeez. And do we have a better solution for this? Nah, I think iterate will work. -1. -1. Smaller than. X plus b. Not x plus b. E plus x. Two b minus 2e. Okay. Let's give this a shot now. Yeah, I feel like it turns out you might be running the same kind of complexity. I don't know if there's a simpler way. Oh, this doesn't even work. So maybe I should start with 0. It's actually likely I should start with 0. We cannot exchange anything. Yep. Yep. This is 100. 0 milliseconds. All I was chasing is 2 milliseconds off. That's all I was chasing. Chasing a method that can shave off 2 milliseconds, but yeah. Wow, that's actually quite interesting. The mathematical solution. Simulation is exactly what needs to do. Mathematics. Oh, you can do a ceiling of this stuff. Yeah, I guess you can. You have delta. It's yeah, b squared minus 4ac. This is basically solving this, right? Solving this quadratic equation. Yeah, you can do that, or you can iterate it through as well. All right, that's it. We got 2 solutions in. Not too bad. I'll see you guys tomorrow.